Okay, we're back with Brody. Okay, Brody.
Alright, so all of our rocks, like I said previously, should not exist together. And so what happened is we have our ancient Laurentian mountain chain, which is our gneisses and granites and very hard billion-year-old rocks. Then we have these coastal water and beach areas that have been transformed into taller, very hard mountains of quartzite. So Gros Morne, our tallest summit, is actually quartzite, and it is a half-a-billion-year-old tropical beach.
Wow.
So it was just bulldozed by those continents, and it formed the mountain over millions and millions of years. It at one point was sandstone, and due to the pressure and heat of the mountain just sitting on top of other mountain rock, it was turned into quartzite. So it has a very high silica content, and you can tell that.
But it originally started as sandstone.
It originally started as a beach, and then it was pushed into sandstone, and then eventually that sandstone metamorphized into quartzite that you see today.
Right. So it's metamorphic rock.
It is.
Yeah.
And
Okay.
it's extremely hard rock.
Right. Okay.
And then as you move further towards the coast, we get the ancient bulldozed continental slope. So leading down into the deeper ocean depths, you had your slope, and now that consists of most of our coastline. So you're going to get different limestone breccias and conglomerates and things like that. And so that's a large portion of our coastline, and that's just our ancient continental slope. And it would have been glued together by various sediments that would have settled in and gotten compressed together. So that's another sedimentary rock.
Yeah.
And then as you move towards the tablelands, we of course get our peridotite, which is our mantle rock.
Yeah, because that's where I'm going to go walking a little bit.
Yep.
Yeah.
And so the peridotite exists only right here. This is actually the biggest source on Earth that you can see peridotite. Some other examples would be in Oman, Cyprus, and Papua New Guinea. And those are all in highly inaccessible areas. And also, if you were to follow this mountain chain all the way down the Appalachians, you can find sources where peridotite may have been metamorphized into different things like serpentinite, asbestos, talc.
How do you remember all that?
I'm a high school student.
Wow.
And then we have the smallest band of rock right here in Green Gardens, and it actually kind of extends into the town of Trout River. And so Green Gardens itself is the ancient remains of our continental crust. And so what happened...
So the mantle is actually below the crust?
Yes.
Jeez.
Yeah. So you have your crust, your mantle, your outer core, which is more of a liquid, and then your inner core, which is more of a solid.
Wow.
And those are the layers of our Earth.
Yeah, so you've got like the Green Gardens there.
Yep. And so Green Gardens is a igneous rock, so it actually arose from magma that was cooled very quickly in an ancient deep ocean. So along the ocean crust, you would have had various cracks and such where magma would have oozed up, and that actually contributed to building our heavy ocean crust. And that process still happens today, along with all these other geologic processes.
Yeah, like for example, the Hawaiian Islands,
Yes,
the Big Island
yep.
is still
Yep,
erupting, and then there's another island forming beside it that hasn't hit the surface yet, but eventually will.
And scientists have seen in various spots across the Pacific that there are actually spots where they believe islands are going to emerge soon, because they can see these very large sediment deposits of this volcanic rock and sand that shouldn't be there and wasn't there 20 years ago. So they think that we're going to have new islands popping up every now and again. And so this is that volcanic rock, but it's actually from the middle of the ocean. So not really a volcano, more of just ooze.
Wow, that's
our
great.
oceanic crust.
Okay, that's great. I'm going to pause it.
Yep.
So Brody is going to actually give us kind of like a context of the age of the rocks, by talking about the age of the Earth. So there's, as you can see, there's a kind of like a big chart, vertical chart. So we're going to start at the bottom.
So
At the very bottom?
Yep.
There we
so
go.
At the
Formation
creation
of
our
the
universe and the formation of the Earth. So billions and billions of years ago, the Earth was kind of clumped together, and it eventually cooled down from this ball of lava and hot rock everywhere to the colder, more wet environment that we know today. And over time, as the rock and magma cooled, we get the gneisses and granites of the Long Range Mountain, And because it was so hot and there was so much volcanic activity on the surface at the time, we ended up with these very, very strong rocks because they were under such heat and pressure. So gneisses and granites are very, very stable in their environment, and they last for an extremely long time, and it takes a very long time for them to erode. And then as we move forwards, we get the emergence of life on the planet and continental action and things such as that. So this is when our oceanic crust would have been splitting apart and creating more oceanic crust, and that's when our Green Gardens basalt would have occurred 550 million years ago. And then sometime between that and 500 to 520 million years ago, you get the Cambrian explosion, which leads to the trilobites. And so the trilobites can actually show us how the island of Newfoundland emerged. So this coast of Newfoundland and the easternmost coast of Newfoundland are actually two separate geological areas. So the easternmost coast could actually be a part of Africa. So trilobites like to inhabit very shallow, tropical kind of coastal waters. And so we have two different species of trilobites on different sides of our island. So we can see that the island was formed by two different chunks that floated together. And then as you move forward, we get the continental action in the middle of the Iapetus Ocean, which existed from 560 to 420 million years ago. And so in between this, the quartzite of Gros Morne was made, that very hard rock that was bulldozed from the beach. And then you get the Green Point rocks, which is the continental shelf that was bulldozed shortly after it. And then in between that, you have
What kind of bulldozer did they use?
continents.
They didn't use, what do they call it, John Deere tractors or
Nope,
anything?
because the dinosaurs were still alive, so they couldn't run it.
Okay, very good, okay.
And so the tablelands peridotite was formed around the same time as the Green Point rocks. And in the Green Point rocks, you can actually see still some of the fossils. So we have trilobites and graptolites all along the cliffside there. And moving forwards, we have the start of the emergence of our first bony fish. And then moving forwards again, you have amphibians. So they would have evolved legs and slowly moved onto the land. And eventually some of them would have moved back into the water, and that's why we have whales. That would have been our mammals and dinosaurs, of course. And so we move on, and then 0.3 million years ago, humans started to emerge. So we end up with this amazing world that we end up with now, and all of these rocks still exist.
Wow. That's fantastic. So there's the, you put into perspective, I mean, if that's 7 feet tall, and it took a step for every year, how long would that be? How many times around the world would that chart be?
Yeah, really. We could definitely circle it more than once if we had to cross over.
That's right. So it's, that's just one, even if we did 10 years, for every yard, 10 or every foot, for 10 years, you would circle around the world a few times, wouldn't it? Yeah.
This park has been a geologic era in the making, so it's taken over 1 billion years to get everything that we see now.
Wow, that's great. I'm going to put it on pause.